So, Christopher, hi, can you hear us?
Hi, I can hear you very well. Can you hear me?
Yeah,
can you see?
sure, and we can see you very well as well. So please, the screen is yours.
Okay, then I will turn on my screen sharing. I will share the overall screen because I have to jump from the slides to the real application. And at the moment, can you confirm that are you seeing my opening slide?
Yes.
Wonderful. Thank you very much. I will hide the thumbnail video so that you can actually see everything. So as I was introduced, I'm a BIM project manager in the Estonian Ministry of Economic Affairs and Communications. Also, I'm in the Tallinn Urban Planning Department, head of digital construction there, but today I'm mostly talking about developments from the ministry level, and the topic is the BIM-based building permits in Estonia. So my presentation is in two parts. First of all, I will go through the slides, give a little bit of background, what is the BIM-based building permit system, and then I will show the application itself, because the slides can be interesting, but I think like the real environment and seeing how it really works says a little bit more. So with the BIM-based building permit process, we started already in 2019. We did a proof of concept with a Dutch company called Future Insight. We saw that the proof of concept was very nice. It was funded by European structural foundations. Then we started building real development, the real application. This tender was also won by Future Insight from the Netherlands and Estonian company Raitviir, who did the user interface and all this part, putting it to the building registries user interface level. The main thing is that with this BIM-based building permit, we can make this process much more transparent than it is right now. For example, already when you are applying for the building permit and you are loading your BIM model, you can already see it. You can already see the automated check results. You can already correct them before you send them to the submission, and you most probably save the time, and this review, thanks to the automation, should be so much faster and efficient, because there are so many different regulations. I will talk about this later on also, what are involved in the process. And the thing is that this solution, it is web-based with a simple user interface, so that there would not be like very many BIM knowledge is needed to use this software. For example, if I make an example of Solibri or Autodesk Navisworks, that you really have to know about BIM to use this software, so that our BIM-based building permit software, it's integrated, it's web-based, it uses also the server computing power, so that when I'm showing the application later on myself, you can see that it's loading quite fast, and with purpose I selected this kind of laptop for showing it, that when I would be using it for BIM processes, I think I would just toss it out of the window after 5 minutes or so. It's not powerful at all. And I will go through also these rule-based and algorithm-based checks when I'm showing the application. And a very important thing to say that we are using the open standards, open formats for the BIM, the IFC, so that you can't actually upload the native formats like Autodesk Revit or Graphisoft ArchiCAD or MicroStation or SketchUp or something like that. But when I was talking about the automated checks, this slide I will go through quite quickly, because I will show you really what are we checking. But mainly I would say that when dealing with building permits, altogether the combination of different regulations can be up to 70 to 75 different regulations. Of course, they are not applying all at once. For example, if we have an apartment complex, there is requirements for housing. This is something that we have also selected for our automated checks, because we want living spaces to be regarding to the building code, and everyone lives somewhere, so that there are a lot of these kind of like housing buildings. But of course, there are different rule sets for kindergartens, different rule sets for schoolhouses, for swimming pools, for administrative buildings, etc., etc. And what we also took in where also what is important for us, the special needs of persons with disabilities, so that people with a wheelchair could really access the building safely, and they would not get into the trouble by using it. Also fire safety requirements, so that the buildings would be really safe to the fire, but with these checks I will show a little bit later on. And what is extremely important, that these BIM models in this IFC format that are submitted, they must meet the BIM requirements. We must have these kind of like common BIM requirements, because in BIM, the walls, the windows, the data can be represented in very many different ways. And if we don't have this kind of like common requirement structure, then we actually cannot say to the computer that check if this wall meets the requirements, because if there is like 10 or 20 or even 100 different ways to submit this data, then we have to describe to the computer as many ways to check it. And this will not actually save the time and the money in the market. It will just overcomplicate things, overcomplicate checks. So the common BIM requirements is really the key. And just some small examples from these BIM requirements. One part of it is this BIM data content table. I would say that if you have the 2D drawings, you have some rules there. What is the line type? What is the line weight? What is the line color? How are you structuring your drawings? What kind of tables you have to put there for your drawings? So that this is basically the same kind of rules for the BIM model. For example, I will show some examples on the next slides, but these are user-defined property sets for the IFC. So we have around 51 tables in Excel format for the buildings. There are many, of course, for the infrastructure as well. But here I'm showing the building part. There are different disciplines like architecture, structure, HVAC, plumbing, electrical. Here on the second column, we have the attribute that is has to be presented in this property set. Also the reference to the IFC, what kind of data type there is, an example, what could be the data, and also at what stage of the building design it must be represented, starting from sketch. Also the preliminary project, where the building permit is applied, also then the main design, the technical design, as-built BIM model, so that all this data doesn't have to be there from the beginning of the building design, but it has to come there during the way in this building life cycle. So some examples for the IFC building. This is the property set for the IFC building, so that there has to be the name, the address of the building, also the height, the depth, the area under the building, also what is the number of the users there, what is the purpose of the building. For example, is it an apartment building, is it a schoolhouse, because a computer cannot understand by looking at the BIM model is this an apartment building or not. To just describe the different algorithms to define it by just the geometry of the model would be quite impossible. But if we have already this kind of like purpose of the usage codes, then we can use these codes and define what is the purpose of the use of the building. Also some fire safety data like special heat load or fire safety glass. Also some examples for the spaces, so that we have to have these IFC spaces to know what kind of spaces they are. This example is for an elevator, so that if we have an elevator, so we know that this is like commonly used surface. We have the category to define what is really the elevator, because the name is quite architectural property, so that one architect can have it one way, the other one can have another way. For example, for the bedroom, we can have master bedroom, guest bedroom, children's bedroom, but by the category, they are still bedroom. And if we want to check the requirements for the bedroom, we have to have this kind of like common property to look into, and this is this category property. Also, there are like these properties like, is it a heated surface, and is it a surface with a room temperature, so that not only do you have this kind of like automated checking, but when we are really checking the things, then we can in addition to that extract this data from the BIM model to the building permit application form, so that when you're filling in this form, you also have to put less manual work into it when you have already this technical data in your BIM model. Also some examples for the building story, for the fire safety zone, for the usage zone, if we have multi-purpose usage of the buildings. For example, if the first building story is, for example, a restaurant, the second building story would be an administration building type where there are offices, and third to fifth story would be apartment complexes with apartments. But there have been also some challenges. Everything is not so easy regarding the legislation and BIM requirements. For example, some commonly used BIM softwares are not capable of exporting all the necessary data to IFC, for example, the IFC zone. One commonly used software for architectural design, I will not name the names, can export everything we need regarding the IFC zone. Another one, competing software, cannot, and we have to find some solutions to that so that we wouldn't really affect the market in a negative way. Also, at the moment, these BIM requirements, they don't have all the necessary data for all the checks against the building code, and we must continuously update them. For example, if we create a check package for the schoolhouses, we might discover that at the moment for the BIM requirements, we are missing some properties to actually carry out the checks, so we must update these BIM requirements as well. And of course, this is quite a difficult task to just continuously say to the industry that now you have to use different kind of properties again. Also with the legislation, with the building code, there are so many different interpretations to just say black is black and white is white, and to make it understandable for the computer. It is quite difficult for some checks. Also the lacking of machine readability in the building code creates it harder because we have to manually describe it for the computer what we want to check. And the renewing frequency, because when we look at the laws, then they are not very old, at least in Estonia. When we look at some regulation, they are updated almost every year or after every 2 years or 3 years. And if we have really many of these kind of like requirements, then we have to always keep an eye on if we have automated some checks, are they still valid, and so on. And also what is really important is international cooperability. If we do something here in Estonia and it cannot be used internationally, then I would say that it's like not so cool thing to do, because we live in an international world, we're globalizing, and all this knowledge that we're creating here, we must use it somehow. But luckily, when we're dealing with the IFC and also with Building Smart, there are some projects already ongoing, the regulatory information requirements and information delivery specifications, so that we can bring this Estonian knowledge also to these projects and have some international gains by it. So, for example, when I was showing you the data content tables for Estonia, there are the different data content tables for Finland, different ones perhaps for Lithuania. But if we have there a column that attaches these requirements with Building Smart Data Dictionary, for example, we have already something international, so that the international part would be Building Smart Data Dictionary, and the national part would be just this national extra that is checked. Also to the implementation, so that when we have already the software, it's not that we have already BIM-based building permits. We still need to pilot these solutions with the local municipality, and Tallinn is going to be a good partner doing that. Also the communication, like how these BIM-based building permits look like, also the learning videos, so that both for the applicants and permit issuers, so that they can really know how to use this software, what to do with it, what is the difference between the 2D building permit and then BIM building permit. Then we have to just climb this mountain and do first BIM-based building permits. Of course, we see that already with this service, there are needed some upgraded patches. We need some new features, also the further check automation. And at some point, we just have to lose the 2D requirements when we're dealing with BIM permits. But at the first steps, it will be so that you will load your regular 2D drawings to the registry, and in addition, you give the BIM model But in this Estonian example, most of the architectural bureaus, they already have the BIM model. They have it, they just extract these 2D drawings from this BIM model, but now they can also use this BIM model for the legal process. Also, the collaboration between public and private sector is important because public procurers are the model client. For example, the state real estate company and city of Tallinn, they both have like 1 million square meters of floor area of different buildings like kindergartens, schoolhouses, administrative buildings, etc. And the public sector client can actually show the way in the industry to start using these kind of like progressive features like BIM-based building permits. And if public sector shows the way, I'm very sure that the private sector will follow. And this is thank you from my slide point of view. And I see that I still have a few minutes. I try to be as quick as possible, but now I will show you the application itself. So can anybody confirm me that the screen changed and now you can see 3D building?
Yes, we can see the 3D building.
Thank you very much. So this is this kind of like 5-story apartment building in north of Tallinn in the Maleva street. And in addition to that, this building meets the BIM requirements. Also, it is geolocated properly so that the architect has only presented this building. And all this surrounding information, it comes from our national digital twin. So that, for example, both the applicant and the building permit issuer can see this this building in the real surrounding environment. And here there are, like on the right side, there are very typical tools like taking off the building stories. We can also create section panes. I will not go very much detail into that. Of course, we have these the background layers. We can see the LOD1 layers, which is like the buildings regarding the building registries information, or the LOD2, which are created by the land board, flew with the plane, with the LiDAR, created the point clouds and the models from there. Also, there will be utility networks. It is not implied yet, but it is ongoing development. So soon we can also see the pipes under the ground in 3D. Also the different base layer maps, we can just take them on, take them off. But what I wanted to really show you here are then these automated check results. So this is the window. There are, at the moment, there are like 3,000 positive check results, 300 and something, I would say, warning messages, and 247 errors. So that the errors are really bad ones. They have to either have a comment by the applicant or then changed. But warnings, they can give this kind of like result that something might be wrong, but it also might not be wrong. Here I will show you some of the results. So for example, if by the building code we have an apartment complex, we want to know that is every living, working and bedroom surface at least 8 square meters. And if we have here like 81 different spaces that are either living, working and bedrooms, to manually check this kind of like requirement by the building permit issuer is a lot of work. But here we can just see by the computer, it's not so hard to check. And if I want to see all the results at the same time, I can see like overview. So what is going on here? So I can see every living, working and bedroom here in this apartment building complex is at least 8 square meters. And why there are some spaces here between, these are these kind of spaces that are not living rooms, working rooms or bedrooms. They are either toilets, corridors, technical rooms, etc. And also, if we want to see, for example, there are different ways that the width of the rooms, the height of the rooms or so, but I will show something a little bit more intelligent for the check related things, so that we have to check if like every living room, like the apartment, which is on the 4th floor or higher regarding the entrance of the building, has the accessibility via the elevator. So we can see that here this apartment is on the 4th floor. There is this kind of like entrance to the apartment. We can freely go to the elevator. With the elevator, we can go downstairs and exit from the entrance, so that this check is just reverse checking it. So can you go out from your apartment? Also, these are these kind of like the first check I would say was the rule-based check. It's just, is it bigger than 8 square meters? This check that I'm showing you right now is combination of rule-based and connectivity graphs, so that we are connecting the different elements, different entities, and having some rules for them. But I will also show you some algorithm-based check, for example, for the special needs of handicapped people, so that rule-based check would be, for example, if we have a stair, and is there at least one landing there if the stair goes continuously from one floor to another, but very like much more what we cannot check by rule, what we check by voxels, by algorithm, by geometry. We check if like 2.3 meters of the free space above the stair is guaranteed, so that we can see here there are little cubes, the little voxels that we start building up. And if we reach 2.3 meters, then we just stop the building and we say that there is at least 2.3 meters of free space. Because if we would just say that, okay, here is 2.7 meters, 2.8 meters, we can go to some extent. But if this would be a stair on this kind of place that you can just go continuously, there is no nothing stopping it, then the computing power would be really a lot, and we would wait a very long time for this check. Also, if we're checking the handrails for this stair element, this is also, we have this kind of like voxel guy who is going through the building, and it tries to fall off. So we have also tried it like this, that we removed this handrail, and then this part of the stair gave us the negative result, so that the voxel finds that they can fall off, it is dangerous, and they will give the result. And one more check that I want to show you, because I'm already, I see 2 minutes over the time, for the fire safety regulations, the evacuation route. I will take this something from here. And here we want to check, is the exit route from the building safe enough for the fire? So that here in this apartment, it's the part of the exit route. So here, this is not safe during the fire. And for this type of building, the exit route has to be smaller than 45 meters. And here from this corner of the space to this door, it is 8.5 meters. So everything is okay. And here, and this is already the evacuation zone, the fire safe zone, the corridor. But to the fire safety department, we also show that from this door, so in this fire safety zone, there is 16 meters to the different fire safety zone, the evacuation zone, and 63 further meters to go downstairs the stairs and exit the buildings, so that the fire safety department can have this kind of like real assumption, like what is the length even when the persons are in the evacuation zones. And for the fire safety department to measure these kind of lengths from the BDF drawings, it takes a lot of time, and to make it safe, they really would have to go through all the different parts. And with this kind of check, it gives more realistic results, and it should save a lot of time. But now I don't want to delay your conference further. So thank you very much for your attention. And if there are some questions, then I would be happy to answer.
Thank you, Christopher. Thank you. Actually, it seems that you have already, done a great job, and there's still a lot actually to do, probably. But one very quick question: does the system checks the acceptance from the first parties, for example, engineer, systems, landlords, etc., and do the third parties get notifications?
I'm not quite sure that I understood the question correctly.
Okay, so I mean, you are doing checks on the building, but for example, we place the building somewhere on the land, and there are some engineering, networks going there, and we have some other neighbor landlords and so on. So do the system check if it's okay with the third parties?
Okay, now I understood. Yes, not at the moment. At the moment, we're checking just the building. And when we have it in this kind of like background, as you saw, then we don't have these kind of checks at the moment, but this can be just checked visually. But very soon, when we are further on automating the checks, then we can, of course, make the checks like this. For example, is the building situated correctly on the land? And when we have already the utility networks which belong to the third parties, we can also make this kind of clash detection. We have already prototyped it actually with some viaducts. For example, if the viaduct pile foundation goes to the clashes for some utility networks, and we got really good results there, and we want to implement it also as soon as possible.
All right. Thank you, Christopher. Thanks again.